Good morning. It's not morning at all, but it's close enough. I am programming. Why is my mic stand not working? Okay, whatever. So, here is a farm. Here is code that controls farm. What did I do last time? I need to review this to remember what I did. It's my harvest code. What's my main code do? It inits a drone, which is our only drone, because I only have access to one. Why is this not scrolled up? There we go. That goes to a specific coordinate, and then it does a task, which is in movement. This has the go-to. Oh, and I pass in the task up here, which is from crops. Cool, we got scan grid, I see. And what does sunflower do? Sunflower is my sunflower code. Okay. So, last time I wrote sunflower code that was really inefficient because I was stupid. I always picked the lowest. I don't actually know if I have it in here right now. I probably changed it. The way that sunflowers work, let me actually just show you what it does now. Start. And we're gonna get to maze solving in a minute, but I want to fill people in. Oh, my ticket code is not running, hang on. VS code, just in case it comes up. Folks are like talking a lot. This file run. Is it gonna run? Installing. Okay, Twitch is started. And I don't have the text up there. Let me show you that. Oh, it's called ticket. There we go. I don't like how it's interfering with the title. There we go. Okay. I'll check back in a minute to see if the YouTube code is working. So what it was doing before is it would just go and it would find the one with the highest number of petals, and then it would harvest that one. But then it would read again immediately, and it would say, is the sunflower below me the highest number of petals? And often it was. Because selection bias, accidentally. It just so happened that it would go to the one with 15, and then everything else would be really low. So unless the thing below it was like a 2 or a 3, it really wouldn't have a reason to move. After a certain point, you harvest all of the big stuff, and you're left with a bunch of small stuff that's really hard to actually get down to. So I changed it. Instead of replanting after I harvest the biggest one, and then I go to the next biggest one. And I keep doing that until I get down to 10, and then I go back there and I replant the whole field. And that seems to be the most efficient. I have a million power. So, that should be fine. I'm sure there's a way to do this a little bit more efficiently, especially with more than one drone. But I don't care. There's no reward for it, right? No, there's no reason to get it. Because the top hat doesn't require it at all. Okay. That is sunflowers. We're doing mazes today. So maze is this thing. Let's take a look. Okay. So we have this weird substance, which you get from fertilizing. Strange effects on bushes. If the drone is over a bush and you call this, so you use weird substance, it will grow into a maze of hedges. Maze depends on the amount of items weird substance used. to get the full field maze, use get world size. Okay. So let's just focus on making the maze happen first, huh? That seems like a good place to start. Oh, this will get turned off here in a second, but it'll be under crops. I'm gonna nuke this sunflower code. And I will define my maze code right here. Def maze. Sure. And then we want a new hat, right? Change hat. What hat is maze? Green? Green is maze. Tree, wizard. You do wizard. Cool. Wizard hat is the maze hat now. And then it's already going to go to its origin point. So what does it do when it gets there? This also needs the arguments from whatever calls this. These. Who is texting me? It's an ad. Great. So we are going to move to the origin. Oh wait, no, that's this. Okay, then what do I need to do? So we should already be at the origin when this function starts. But we want to do this in a loop, right? While true. We want to movement dot go to. This should be fine because I think the maze breaks after you harvest, right? So you don't need to traverse back out. And I will just steal this. Then we want to plant a bush. How do I have this out to plant a bush? I was just calling replenish. It tills, it plants, so I'll just call sure. It even does bush by default. What is it? Harvest dot. I was just looking at it. Replenish entities dot bush. Is capital B for bush? Yeah. Bush. And then our little helper here, our little guide. We're going to use item. And then the amount we're going to calculate. Ow. We can calculate this at the start. Substance amount is this, and then get world size we're to change. So some number, which should be just the width, right? So it needs to be a square. So we're going to assume it's a square based on the width. Let me note that down. Here we go. Width length must be square. Finish. Use enemies. This must be equal. Cool. Let me add a check for that. If width does not equal length. Is not equal a thing in this language, in Python? Or is it not width equals length? I think that's fine. I hope. Then we want to change our hat to a traffic cone. And then we want to quick print error width not equal length. There we go. There's not actual error handling in this version of Python, so we got to do it like this. Then we calculate our sub amount, which is this. Then we go into the main loop. We use the substance of the amount, and we should make a maze. Let's test this out to start. Error, bracket close. Where? Where? Oh, is it a fake error that wasn't real? Because it's gone away. No, it's still freaked out. A bracket close is expected here. Why? Oh, this should also return. Am I missing something? What did I fuck up? Oh, here. Okay. So now we get a maze. And we're gonna have this as a, let's go 5 by 5 for now, because I don't know what's gonna happen. Starting at 0, 0. Error. Oh. Dumb. Dumb. Hey, let's chill out, okay? Is there an actual debugger? Am I stupid? I see. Okay, so this is a good look. The maze is completely enclosed, so there's no origin point to go in or out. And now we've got some interesting business here. So here's how I think I'm going to conceptualize this. I'm going to treat this like a graph, because it is. Now, this is a good moment for some education, so let me think about how I can do this. Got a VS Code window? Okay. Can I change this to be... I don't know, could I draw this in like Pixlr or something? I don't have identifying information in Pixlr, right? No, not Express. I don't need the AI stuff right now. No, some photos of snack, some D&D stuff. Yeah, I should be fine. Let's make a new something. Oh wait, I can just pirate stuff for you like normal. Does Windows still come with Paint? Paint? Alright. There we go. It's a bit safer than letting it open in my browser. It's not detecting the Paint window. What the hell? Oh, there we go. Entitled Paint. And then I show this, and it goes right here. There we go. And you can't see anything. What? Why can't you see anything? That's quite annoying. Why? Wait, you can see something, it's just not useful information. Can I refresh this? What is wrong? Maybe Windows 10? There we go. Does it update properly? Yeah. There we go. Cool, and I can erase and everything. The eraser is too small. How do I make bigger? Is it no, it's not Alt. Oh, that really screwed me. Here we go. Cool. All right. Now, graphs. No. Graphs. How do they work? You can hear the music, by the way, right? Yeah. Cool. And I'm audible. Great. Graphs. It's not like in math when you've got your X and Y and then you've got like a line graph, right? Or like your complete Cartesian plane, you got your rise over run or whatever. Graphs in computer science are much different. You can do those sorts of graphs in computer science because you can do all the math you want in computer science. Technically, you can't do all the math you want, but you can kind of do all the math you want. Graphs in computer science are nodes, which we represent with a circle. And lines, which I will draw by hand for fun and flavor. And we can kind of think of this the same way on mazes. Cool. Let's jump back to maze. So here's how I'm conceptualizing this. You've got our straight lines here, which are our connecting points, and you've got ending points, which connect to other points, right? Those are the nodes. So we start on a node. Right now we're in like this long corridor here that ends, right? You can't go this way, but you can go this way. Oh, we're trying to get the treasure chest, if that wasn't clear. Then we've got another node right here. Right, this node connects to this point, and this point. This would be a bit more clear in a bigger maze, I suppose. Then we've got a node here with the treasure chest in it, which connects to this one. A node here, which connects to this and this. A node here, which connects to this and this. And you can tell that if there were branching paths, like this one here, where you see it connects to this way, and this way. Let's zoom in just a bunch. This one, where it connects to 3 different options, right? How it'd be sort of building out like a spider web of nodes. So, if we wanted to break it out just a little bit, I can put this on a different window. Genius. Great. Can I duplicate this object? I've not used paint really ever in my life. No, I don't want that. How do I just select something? Selection? Uh-oh. Okay. So this will be our root node. That's where we start. So let me move off of that window. The root node is where we'll start, and then we connect to one node, which connects to the treasure node. This node also connects to another node here, which connects to this, and this, down a whole path that we're not going to look at, or that we don't want to go down. Right, so we start up here. This is our starting. And our ending, our treasure, is here. And we've got a bunch of blank space that we're going to travel through. So first we move to here. Wait. No, black. First we move to here. That is starting to here, right? That's 0, 3. And we're going to do the math on coordinates here in just a second. Then we can move from that crossroads either to our treasure node here, or into that kind of windy bit that we don't need to go down. Right? Can I do text in? Yeah, I can. Cool. 0, 0. Is that legible? It's too small. There we go. That should be readable. Then we got 0, 3. Right. This is very hard to select. And then 0, 4 is our treasure node. And then a bunch of stuff that we're going to look at in just a second. But you can kind of get the point. I hope you can get the point of how these are connected. Boop. If I were better or had more time, I might make a program in the game that would actually let you see how it's connected. But right here we've got 0, 0, 0, 3, 0, 4, and then the other path that we don't want to go down. So, let's see how we navigate now. Oh wait, is this actually doing 10 by 10? Oh, it's 5 by 5, which is 0 to 4. Right, cool. I'm glad that math worked out first try. For some reason the drone can't fly over the hedges, even though they don't look that high. That's fine. Treasure hidden somewhere in the hedge. Using harvest on the treasure to receive gold equal to the area of the maze. Okay, 5 by 5 equals 25. If you use harvest anywhere else in the maze, it will just disappear. Cool. Get any type is equal to entity's treasure if the drone is over the treasure in the entities.hedge everywhere else in the maze. Cool. So I will write a check for that. Mazes don't contain loops unless you reuse the maze. So there's no way for the drone to end up in the same position again without going back. Got it. My program will likely just account for loops on its own. You can check if there's a wall by trying to move through it. Move returns true if it succeeded and false otherwise. Can move can be used to check if there's a wall without moving. Okay. If you have no idea how to get to the treasure, take a look at hint 1. Using measure anywhere in the maze returns the position of the treasure. Interesting. So that's information I might not use, because I want to take this opportunity to practice graph traversal. But that's fine. I can actually use measure to determine which route I want to take before all the others. That's fine. For an extra challenge, you can also reuse the maze by using the same amount of items.weird substance on the treasure again. This will collect the treasure and spawn a new treasure at a random position in the maze. Each time it's moved, some of the maze's walls may be randomly moved. So reused mazes can contain loops. Interesting. I don't know why it's set up like that. Treasure can be relocated up to 300 times. So I want to know what move returns, and I need to break the loop at the end for now. Eventually we'll go back to the start, but for now I want to try and solve one maze rather than solve like 80 of them. Let me check up on my code really quick. How is this running? YouTube is starting, listening, cool. Great. Fantastic. Perfect. Okay, so first I want to measure. On the maze. And then I want to check what move returns. I guess quick print move. Cool, let's just see what this does. Move takes one argument. I called it with these arguments. Okay. Is it can move? Oh, and then you pick a direction. Right? So can move, north will be true. But then can move east will be false. Oh, I spawned a new maze. Can move west will always be false here. And then I need my output. True and false. And then 4-1 is my treasure. Cool. Okay. Let's talk about movement. So there is a way to solve mazes that is very simple but takes a long time. Now this is not graph traversal, I don't think. It is technically, but it's not really. The way you solve a maze, if you want to be guaranteed a solution, as long as there's no sections that don't touch a wall, right? So imagine that this wall wasn't here. This whole section would really screw you. But in the case where every wall of the maze touches an outer wall at some point, if you put your right hand on any wall, and then you walk forward, keeping your hand on the wall the whole time, you will eventually solve the maze. Same thing for left hand, right? You just take the longer path all the way around, and you can see how this is very inefficient, right? But you do eventually solve it. I'm not going to do that. I could, I won't. I need to create a routine that moves and scans in a direction. which means this is very complicated. Okay, first I need to graph everything, which means I need to define what a node is. Now, there's no classes in, no, that's a little bit dour. I don't want that. There's no classes in this version of Python, which is very annoying because that's how I'd solve this problem, is to use classes. Instead, I'm actually going to break the maze out into its own file, because this is going to take quite a bit of code and like custom stuff at that. Maze. This needs to import our maze code. Come on now. Import maze. Lowercase. Def main loop. And our main loop is going to take all this stuff. And then it will be this here. Go, all this stuff can move in. We will actually calculate the substance amount inside the main loop here. Okay. And like the sunflowers, I'm going to limit this to only one instance of this per world. We can't have it trying to solve 2 mazes at once. Cool, that's fine. Maze dot main loop. Oh, this could actually cause issues. Let's call this mazes, huh? That'll be fun. Or treasure. Treasure. There we go. Pass this in. And now, I need to write some fun code. Let me try and get this as big on screen as possible for you. There's no way to increase the UI size, I don't think. Let me check. Who is messaging me right now? It's TikTok. Cool. Don't care. Graphics? Devs? Oh, UI size? Did that work? Not really. Okay, I'll just be zoomed in. Okay, so here's our main loop. Where to keep this, I suppose. Or no, because I need movement, so I need to import that. Movement, main loop. Now I need to keep track of the graph. Probably means I should have another file for just the graph. Right, I'm gonna just double check that there's no classes, because that would make this very easy. I've already searched for this. There's still no classes. Sorry, I'm reading this form here. This is very strange. Someone asked to have classes in the game, and there was quite a bit of argument. Okay. So that's just not gonna happen. Even though classes would be really useful. They're very, like, an efficient way to lay out your code. So yeah, I'll just make another file. Because I'm gonna have to do this in a C-like way, instead of in a Python-like way. Can I not link these? There we go. Graph. And the graph is going to be made up of nodes, so I guess I will just have a nodes list. And then I will have a, well, I guess that's all the graph is, just a list of nodes. And they are linked. And I'll need to find a schema for how nodes are attached. So each node will have a address, right? So it'll be an XY coordinate. And then it will have a type. Oh. I wish that song was longer. It will have a type which is either what is the default? Hedge. Okay, hedge or treasure. Okay. We can have a visited, which will be useful info. That'll be true or false. And then we can have a neighbors, which will be a list of up to 4 separate nodes. Excuse me. Which will have an XY address. Here's a question. Do I actually want to make these tuples? It doesn't matter. That's just kind of wasting space. And then our neighbors, which will be, they can't reference nodes directly because we don't have classes. But they can be the coordinates. Oh. This will need to be a tuple as well. And your graph can have as many neighbors as you want, although in this case, it can only ever have up to 4, right? Like, what's the most we have here? This one's got 3. This one's only got 2. So yeah, it's either going to have 1. Yes, you can have, so your node's either going to have 1, none. No, 1, 2, 3, or 4. So yeah, cool. And that should be all we need. That should be all we need, I think. Excuse me, oh my gosh. I've been a little bit under the weather today. Cool. So what do I want to do? I guess we'll add node should be a function. Def add node, and then we need all of this information, right? So its address, its type, visited, and we probably need a list of its neighbors, yeah. Am I spelling neighbors correctly? I'm just looking at it now, it seems weird. No, I think I'm fine. I'm not the best speller. Oh. Hey. Oh. Cool. Now, this is really as simple as nodes dot append well, just this, right? Oh, you know, I can make it a set. You know what? It should be a set. Okay, let's make it a set. And it'll be a set that's a tuple of an XY and this dictionary. How do you find sets? Just like this, right? Oh wait, you can't change sets, correct? Python sets. Set items are unordered, unchangeable, and do not allow duplicate values. That could be an issue. I think this will actually be fine. The reason I want this to be a set is because it needs to be, the order does not matter. And all the values need to be unique. Yeah, but that doesn't really work, does it? No, we can make it a list. That's fine. We'll get some better functions. So first we actually want to check if okay, for node in nodes, if node 0, which is our XY address there, is equal to our address that we're passing in, we need to return false, meaning we've already been to this address, or we already have that node, we don't need it. Otherwise, we do this, we return true. Bad on the type here. We can also update our node. With the same values. Nodes dot. What does pop do? I can't see. Okay. Okay, why does remove turn none? That's kind of annoying. I feel like remove should return the node that you removed. I need to remove the whole element. Which is really annoying, actually. Just realized this is wrong. And I actually need to pen in what these are, right? Type. Visited. And neighbors. I guess then we'll remove this here. Can't even do that. That's unfortunate. I guess I could have it search for the address. So we just search for something with this address, we remove it, and then we add it back. Cool. And then I want to check found node equals false. Down here, if found node equals false, then we can return false. Cool. So we check if the node exists. If it does, we update it. Otherwise, we return false because we didn't find it. You know, I could be a little bit smarter about this, actually. Instead, we're going to update something in place. Instead, we're just going to move this here. And then this will be our false condition, as if it exits the loop without getting to that. This can go away, this can go away. Very simple. So it loops through. If it finds the node, it appends it. Otherwise, it just returns false. Calls it a day. Easy peasy. Peasy easy. What else do I need? I think that's it. That should be it. Just add node and update them. That's all I really care about. We have the nodes graph here. We'll come back to this now. Now, the complicated part is navigation. So there's not really an option to like move forward. So we need to do some grid math here to figure out which direction we want to move. And decide what directions we can move. So the first thing we want to do when we start, before we even go into the loop. No. Now we need a second loop, which is the maze loop. Oh, shit. Hang on, what if I call this something else? Maze loop. And then I'm gonna move this. Welcome to programming, folks, where you realize the problem is complicated, and you have to restart a lot. Well, true. Maze.main loop will change to maze.loop because I don't want to type maze so much. Maze.loop, we give it those whatever's cool. Gotcha. Now here's where we're going to solve everything. Or some stuff, I suppose. What is the first thing we do when we get inside the loop of the maze? Or when we prep the loop of the maze, anyway. I think the first thing... Okay, I know that there's an error. I'm just looking at my code. Chill out. Is we want to add our first node. We actually want to add 2 nodes. I need to import. Import graph. Cool. Now, graph dot add node. The first node we're going to add is at our origin here, where we start the maze. It's going to be of type, whatever the type is below me. How do I get that again? Get ground type. Oh, I just wanted to scroll this up a little bit. There we go. I want to make sure everyone can at least see a little bit of what's going on. So we get our ground type. We want visited, which will be true, because that's where we're at right now. And then our neighbors, we don't know. So we'll just give that as an empty list and call it a day. Cool. Let's comment this. origin node. And now we have our treasure node. Which will be at measure. Measure, it'll be what? Entities.treasure? And false. So these will be the two nodes that we know about. And I'm going to have it quick print. Graph.nodes. Just so that we can see what happens when the maze starts. This should be interesting. Let's see if we get an error. I imagine we will. Import maze. A module with this name does not exist. Bite me. Oh, it's right. It's right, actually. Alright. Good on ya. Module with this name does not exist. Can I fucking change the name? No, cut it out. Why can't they change it? Alright, everyone. I'm upset with the program now. Maze. Fuck. Game is broken. Maze. Son of a... Fine. Why can't they change anything? This is very frustrating. And I broke it. Damn it. Well, this will be the one that's named incorrectly. And I'll get flamed for not following my own standards. What? Okay, that's fine. Cool. Yay. Change that to treasure. Cool, cool. Maze has never been defined. You're right. You're so right, and I love you for it. Cool. Now we've got this maze. 0, 0 is our first node. Grassland. Oh, that's not right. That's not right at all. This should be type hedge. How did that happen? That's not right. Game, I found another bug. Unless I'm stupid. But we used the item here, yeah. Any loops unless you reuse the maze. And move through it. Same position. I'm getting the ground type, not the entity type. I forget that we're an entity. Cool. Any type hedge, visited true, visited false, neighbors, none. Visit 0, 1. And it is. So that's good. Now, what do I need now? Now we need to decide how to move. Now we need to decide what nodes are around our current node. I actually don't think I need to add the origin node first. Let me give us a loop here. You can't see this at all. Okay, while true, so first we're going to work on our node here. I guess I will scan node. Okay. Oh, not, yeah. Wrong type of thing. Does not need to be the origin, because we don't care about that. Not new node, just current node, right? We'll scan node. Or I guess it shouldn't be current node, it should just be current ground. No, it should be current node. Graph add node, current node. Okay. I don't know why it doesn't see this. That's very strange. So what am I going to do about this? The first thing I need is the address. Address is equal to get position X get position Y. No. Get X, get Y. Our type. Get entity type. Visited, we will check for next. So for node in graph.nodes. I guess we could add this to the function, right? Yeah. Yeah, that's fine. Get node. There should be an address. It will just return a node if we're on it. Otherwise, it returns false. Address. My brain is not working. For node in nodes. If node 0 equals address, return node. And if not, that never happens, return false. So I can change this, right? If get node address, that it could be our fail condition. Now that I've got this code. Oh. Cool, and then I can also change this down here. Nodes. That'll probably need to happen regardless. No, that's fine, I can leave it. No, nodes. There we go. We'll see if that actually works. I don't know if you can assign like this, but well, can in normal Python, I think. Cool. Node. Ugh. Turn false. Turn no. Okay. Can't do an assignment here. Cool. That's not what I wanted. But I guess I'll live. Now, look at our loop. Scanning the node, so now we get the node, if it exists, based on our address. If node, then we just return the node, right? Else, we want to scan everything around it. Also, we want to give it a type. We want to set visited to true. And now we need to check if we can move in any direction. Scan node should probably take an argument. That is the node we moved from last. I don't know. I'll figure that out in a second. For now, I guess I can just set its neighbors to none. Scan node definitely needs to check its neighbors. Okay, so now we have this node. Now we need to check if our last neighbor This is much more complicated than I expected. Hang on. I need to think. Let's just keep track of the last node, which is going to be an index. From the graph nodes table, right? Oh no, but we keep removing it and re-adding it. I feel like our update node needs to change so it doesn't remove anymore. It should just be node 0 equals this. But node is a copy. Pisser. So get node should return the index, but the index can't be 0 because 0 is false. This is very frustrating. Now this returns null. Or none. And instead of being node, this will be node index. Now we don't return none, we return for I node enumerate. Cool. Sure, that's fine. Node index doesn't equal none. Then nodes. Node index 0 be equal to the address. Cool. There we go. That's complicated, but that's fine. The reason I'm doing it like this is because I need to edit the... Oh, thanks, Nightbot. Nightbot definitely just got someone. Excited about that. I need to edit the graph in place, which means I need to directly access all of the nodes here. Give it a new address, give it new types and things. Tuples can't be updated like this, can they? No. They need to be a list. Just a fixed list with a limited set of numbers. Fine. Fine. That's fine. Now... node index. If node index does not equal none. Node index equals none. We do all this rigmarole. Otherwise, we do something else that returns the node graph dot nodes node index short. I needed something with a little bit more energy that keep me awake. True. Now I need to set what if I have scan node in the graph? No, that doesn't really make much sense, does it? Okay. Now we want to set our last index. I need an edge case here. If last node index equals none, then type visited neighbors equals this. So neighbors does not equal none, then we will set, we'll have to do some to-doing. Otherwise, we can add node to I need to start taking some better notes here so I can keep track of it. So the node's not in graph here. First node in the graph has no last node to go to. Should be not first node. Not first node in the graph. Then we add a node with the address, with the type, with our visited status, and our neighbors. Right? That seems right. We'll do some more checking out here. Now, Actually, let's just take this out to out here. So it's going to add the node no matter what. And then we can update the neighbors after the fact for both, right? That should be fine. And then we're going to return the node anyway. Does add node, does append return the, it returns none. Great, great. What I'm hoping would happen is that append would return the index of what we just added. But it does not. So instead I need to get the list length minus 1. Cool. If add node graph dot nodes one oh, you know what? Now I just get the graph node index again. Here. Because now I'll actually have it. Because it'll be in the graph at that point. Then we go out here. We check if we're not the first node in the graph. And if we aren't, we want to update that. Otherwise, we're just going to return the graph at our node index and call it a day. Which is fine. My head is starting to really hurt. I'm a big process programmer. I'm not very keen on algorithmic programming. So like all those little fiddly bits like this, where you're trying to very carefully like lay out a data set, or not a data set, where you're trying to like very carefully traverse a graph or make decisions like this, not my game. I'm better with things that are going to be like a fixed process that would be essentially what a human would do, but just much faster. Okay. Humans don't tend to solve problems like this, so in this manner, they solve mazes every now and again. But you wouldn't solve it the same way. There's a net I just caught. That was great. Good job, me. So maybe the last node index, we set our neighbors to none? No. Now our neighbors are going to equal graph nodes last node index. Zero. Or no, 1. Yeah, this should just be an address, right? And then our last node index. is this node. And then graph.get node here at the address. This is missing quite a bit of error checking, but there's no error handling, so I don't care. And then we want neighbors. So the reason that this looks as messy as it is because it's structured to look like C, like a C-type language. But this is Python, which should have access to object-oriented programming, so it should look a bit more like Java or JavaScript. And it doesn't, for reasons, I guess. I find this much more difficult to read. Essentially what this is saying is, look at the graph. We've got our nodes. Then we want to get the node address, or we want to get the node index for our last node address. And then we want to grab 1, which is this dictionary, and then we want the neighbors list, and we set that there. Now, no. Close, but no, actually. If I'm passing in the address anyway, then this is fine. This doesn't need to be the last one. This needs to be our current node index. Now we want to loop through the neighbors for neighbor in neighbors. If last node address if neighbor 0, no, just if neighbor equals last node address, then this should break out of the for loop because we're good. Already in excuse me. Okay, I will check this a second. So this is the case, so we check if we're not in the right. Alright, we already have the neighbor at the last node. So we'll do something here, I'm not sure what. Otherwise, if we get out of the for loop without hitting this condition, we will graph.these.append our last node address. There we go. Cool. So I need to check, essentially, for this. Dot this neighbor. It's going to be equal to false by default. This will set it to true. If not got this neighbor, we will add the neighbor. And then to finish it off, we just return the graph node index. So essentially all of the info that we had on the current node. Cool. I guess I could just have it return the node index. So the current node is going to be... let's just keep track of the last node. It's going to be equal to none by default. The current node is going to be graph dot nodes. This. Oh, but if it's false? Oh shit, if it's false, that's not good. Current node index. And then we don't need to add the current node at all. Because we already do that. Okay, let's just see what I messed up. Error. Enumerate has never been defined. Are you sure? Can I do for loops? Where are for loops at? For loop. That's annoying. They don't have enumerate? So, just a heads up, if you play this game, you're missing out on some fairly basic functionality. Enumerate does not show up anywhere. That's great. Very cool. I guess I will do this by hand, which will not be fun for anyone. Yeah, this language is not set up to do stuff like this. Cool. It's just a bit wordy now. Sure was not defined. Okay, this needs to be graph.add node. Did I make that mistake again somewhere? Probably. Did it run? No errors. What are we getting now? Same thing we got last time, which is perfect. Cool. Now, let's make a quick distinction here. What we count as a node and what we don't. Anything, the first thing can be treasure? Oh. Shit. Okay. if a node, or if a tile, let's call these tiles, if a tile has if a tile either only has one neighbor or a tile has two neighbors and changes directions, or a tile has 3 or more neighbors, it is a node. So this is a node because it's in a corner, right? Or it's in a dead end. This tile is a node because it changes directions. You can go south or east. Yes, that's east. This is a node because you can go south or west. This is a node because you can go north or east. This is not a node because you can go east or west. And you can't go any other direction. So node, 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 not nodes. These are a space to be moved through on your way to other nodes. The reason this is set up like this is because there's no way for me to really determine the orientation of the copter. There's not like a way to check for forward. I could write that, I guess. Also, the node.type doesn't really mean anything here. I'm going to change that. I'm just going to remove it. I want to know if I visit it and what neighbors it has. That's all I care about. The type is something I'll check for each individual tile. No types. Take types out of it. If I need to add it back in later, I can. But, like, it didn't serve me much. Oh. Cool. Type is now gone. Now let's debate about movement. So I could set up a movement scheme where the copter has orientation. So we always know what direction it's moving. The trouble is kind of keeping that instantiated. Let's first add... Okay, let's add a check for is node, based on the criteria I just said. I want to move my graph over here, because that should be more or less done now. Def is node, and that'll just return either true or false. Now how do we know? We know in those conditions I just said. So it's either got only one direction you can move, Do I care about the direction change? I don't really care about the direction change. I should just write code that manages that. So 1 to 2 directions you can move. No, only 1. 3 to 4 directions to move, right? Cool. So the first case should be pretty easy. We just need to check which directions we can move. Movable directions? No. I'll just check movable. Should be fine. Also, for now, I think I can set this to pass, right? Pass. Yeah. Or no, this will call movable. We'll return a list or just a list of directions that are viable. So directions. Whoops. A list if can move north. Then we will add north, south will be our first two. Am I spelling directions right? No, I'm not. Only 1 are in direction. What? What button did I press? Sorry about my horrible spelling. I'm realizing that I need to severely expand my music palette for stream, because it's very small. South. Can move east. North, south, east, west, never, soggy, eat waffles, great. And now I just return directions, right? So now I get the directions from movable, which just tells me which directions I can move. Only 1, which will be if len directions equals, oh, hang on. Equals 1. For now, I'll pass. No, this is a node, so we return true. elif, the length of directions equals 2. Well, there's only one case where it's not a node, right? It's if directions equals 2. So I guess let me be a little bit more concise. Elif directions is less than 1, or if it's greater than 4. Change hat. Did it just take away my... Okay. Hats dot... And then we will freak out. Cool. And then our else case is here. Also, this should, I don't know, just loop. No, I'll just return false. Okay, I'm actually take a quick break. And returned. Okay. Back to what I was doing. Programming. We need music. What music do we need? Hopeful music? No. Sure. That's fine. We're checking if we're at a node. So this is our error case. If it's too low or too high, we freak out. And then if we're at 3 or 4, we can just return true and call it a day. Return true. There we go. One, 3, or 4. Right, and then want to double check that. So that's if we're in a stop spot here, we can only move 1. If we're in a spot like this where we can move 3, or if somehow we get to 4, that should be fine. Who is texting me? It's work. It's work. That's not important. Also, if you're wondering what being a programmer is like, you get a lot of questions after hours. People want your attention a lot, because this is magic to like 90% of people. Well, like 80% of people. This is just magic. All of the words on screen. So people don't take initiative always. So you just get a lot more questions than normal. I'm sure the same thing is true, like, if you run an auto shop or whatever. You're probably constantly getting questions from your family and your friends about, like, my car's not working, can you look at it? That's me constantly with computers. Okay. So first we scan the node. Well, we should check if it is a node, right? So if is node, then we set the current node index, we scan it. Otherwise, what do I do? Otherwise, we'll do our movement thing. So we do a special movement thing. Do we do a special movement thing? No, this is mostly just to determine what direction we go. Otherwise, we move. I kind of knew the general gist of what I was getting into. But the specifics, like, if we look back at our little graph here, where did that go? Is it 2? No, that's the farm was replaced. It's this one, paint. There we go. If we look back at our little graph here, I had this whole thing figured out, like how all of it works, and then the actual implementation is really much more difficult than... That's not what I'm going for. Is much more difficult than what it's like when you solve this stuff on paper. Because the actual traversal from one node to another is kind of complicated. So no matter what node we're on, I want to check if... Oh, I'm not in the window. I'm just typing to nowhere. If get entity type is treasure. Equals entities.treasure. Then we can harvest. And then we can return. Yippee, we did it. Yeah, that's fine, right? Because we return, that breaks out of this loop. That loop goes to our crops, which is treasure right here. Right, and then that'll go back to... That'll move to the go-to here. I actually still want this to break. So that jumps to the go-to, and then we replenish, so we plant a new bush, we resubstance it, and then we loop again. Gotcha. Great. Great news. Okay. Once we're at a node, can this start and not a node? No, because it's always starting in the corner. That's good to know. Wait, no, this isn't a node by my definition. Okay. So in my loop then, I want to track what direction I'm moving. Actually, maybe that's just a global maze issue, right? So facing. And by default, I will be facing towards north. So I'm always facing this way. Uppy downies, but just up that way. There's no compass. North is just up. And then this should be global. I'm gonna make this global. I'm gonna make this a bit more like a class and a bit less like not class. So we don't need to pass this in. We just have it. True. And then we want to get which directions we can move. So let me pull that down. Directions equals movable, like this. Cool. And now we want to decide how we move. I think in the final version, I will choose which direction we move based on where the treasure is. For now, let's just move in the direction we're moving. Actually, that makes a really good case for this being none then. Because when we first start, we won't have a direction. Okay, so if facing equals none, then we need to pick a direction. So we get our movable directions. Cool. And the first thing we want to check each time, just to save on cycles, if for whatever reason the treasure spawns right under us, which I just figured out is possible, is we'll just check for treasure, and then we'll harvest it and return. So we'll get the directions. If we don't have a facing direction, we will pick one from movable, which I will just pick as directions 0 is going to be where we're facing. And then we're going to move in the facing direction. And that should be fine. Do I have an opposite function in general? I think I do. Direction toggle. Okay. I guess it's not possible to have a different direction, but that is funny. Good job past me. You made me chuckle. Facing, quick print, graph modes. So I guess we'll check if we can move the direction that we're facing. Then we will. Otherwise, okay, hang on. Is node else? So we need to set our facing direction first. Here. And then we're going to check if we're a node. And if we're not a node, let me just add some quick notes. Yippee. There we go. Where we can move to. Facing is only none on first tile. Sure. Is node is 1, 3. We just know if this is a node. If it's not a node, we will now need to pick what direction we're going. Right? Let me write that down. I spelled direction wrong again. Else we just pick what direction to move and we call it quits. The is node is where we gotta do all the path finding. Otherwise, we're just gonna truck until we get to the next node. Node. We only scan the node here. Does scan node add node? I need to remember. Yes. Me make that note. This returns the spelling. Graphs.nodes. A new node, if not exists. Cool. Mobile directions, cool. If the current tile is a node. And then loop is just the main loop for mazing. Treasure node. Oh. You know, Threads gives me too many notifications for an app that I don't use, so I should probably turn those off. Okay. Now I either want to move the way that I'm facing, or I want to pick a new direction that's not turning around. So if can move in my facing direction, then I will move facing. Right? Otherwise, okay. Then for, let me just make a new function for this. No, hang on. Let me think some more. For direction in directions. If I can move in this direction, and the direction does not equal, so basically if it isn't turning around, oh no, I just want to change what direction I'm facing. So that's fine. If this, then I'm going to make it its own function. I've decided that's the best way to do this. Move, pick, facing, symbol. Cool. Pick facing, node, which will be pass for now. And pick pet the piggy. Pig facing, simple. Cool. Should be path. I should be consistent. Here. That will do this. That gives me a little bit more flexibility with how I write the code to make it a bit clearer. Who is texting me, man? Is it another ad? You wouldn't believe it. Alright, I need to turn my ringer off. So if we can move where we're facing, then we're just going to return. If we can move in a direction of the directions that we can move, I need to add that. Hang on. Pick, facing, path. This is a little bit convoluted, but it'll be fine. The return 4 directions in direction, or 4 in directions. If we can move in that direction, and it's not the opposite of our facing. Import general. There we go. That's what general.opposite. General.direction toggle. So basically, as long as we're not turning around, pick this one. Then we will change facing equals dir, and then we return. Let me number these just for clarity's sake when I go to read this back later. So the first thing we want to do is, can we move in the direction that the drone is facing? If not, number 2, can we move in any direction that is left or right of the drone? And our last case, our else case, that is 3. We're going to turn around, but this is also an error case. This last one here should never run. Because that means if we can't turn left or right, it means that we're at a dead end, which means we should only have one possible direction to move, which means that the node should be picking, or this section, the node direction should be picking where we go next, not the facing path. Facing equals direction toggle. And then also change hat to be an error hat. Hats dot traffic cone. unexpected case. Okay. Sure. Like, that gets the point across, I suppose. And then we're going to move the direction that we face. I'm actually going to check if we don't move that direction we want to error. Basically the same thing as this. I should just write code that is an error. That might be better than copying this all over the place. I'll go back and do it later. Unexpected movement failure. Cool. For now, I'm just gonna pick a direction to move using the same algorithm here and just pretend we're not a node. That'll probably cause an error at some point. Wait, what? Oh, I missed a colon. Tried reading variable facing before the value was assigned to it. Is it not assigned up here? Facing. Where was it freaking out about that? Right here? What? Huh? That's not right. Why is it like this? Oh, I need to modify a global variable. I see. Okay. Let me add it. I don't have to do that for graph. I feel like Python applies this rule inconsistently. Let me just triple make sure that this is not gonna fuck with me. Directions is fine there. Last node address is a global address. There we go. Let's see if that does it. Let me also move this code up here. No, I decided against it. Cool. We moved in a direction. Will you look at that? Brilliant. Notably, this wasn't a node. Also notably, it is not looping at all. Let's see if this breaks and how badly. Hang on. It's gonna take 0 arguments. Good thing I caught that. Okay, so this technically can solve the puzzle. The trouble with how this solves the puzzle is that it's random. It just picks a direction it moves, and it's not picking a random direction, so it's not like it'll ever even solve it. Guaranteed. But it can solve it sometimes, so that's good. And we made 25 gold. Wow. Yippee. So what do I do now? Now we need to do all the pathing for when we're on a node, which direction we decide to go. I'm fine with the first time we move, just picking a random direction. But once we actually make it to a node, we want to turn to go towards the treasure. We also want to do searching. So, in a graph, where's my graph at? Is it? It's VS Code 1. Let's say it's visible, but I can't see it on screen. Whoa. Okay, here we go. We've got shapes on screen right now. I need more circles. Circle? That's really more of an oval. That's fine. I can lock it to be a circle. Brilliant. Cool. I'm going to half-ass this really badly. And sure, we'll do this. Let's talk about graph traversals. Who likes graph? Can I make this window bigger? I can. You're gonna learn this. So, oh wait, I need to move this here. There we go. Fine, brilliant, good enough. So we got a graph. We start at yellow. We're trying to get to green. Now you have got two options. You've got a few options. There are two big options for graph traversal. The first is called breadth. Hang on. I'm writing with a mouse. Breadth first traversal. Okay, I'll spell it out for you. I know listening is difficult. First. Okay. Traversal. Okay, breadth first traversal, right? Now what that means is that we go as wide as possible. We go for the breadth. Breadth is wide. I was gonna think of something funny to say, and then I just didn't. Did someone else get nightbotted? No, just one person. One bot got nightbotted. So when we do breadth first traversal, the first thing we do is we look at the first node, and we check if there's treasure there. Or we go to the first node and we say, do you have treasure? And if it doesn't have treasure, we didn't find treasure along this route, we go, well, let's go back and let's explore the other path. Then we do that. We explore the other path and we go, did you have treasure? No? Okay, then let's go deeper down in the graph. Right, so we've checked this one. Checked this one. We've honestly checked the route. Then, you know what? Let's number these so that we can be at least a little bit consistent. 1, 2, 3. Tell me if this isn't clicking, by the way. 1, 2, 3. Then we go, well, we didn't find it at 2, we didn't find it at 3. Let's go deeper into the graph now. So then we go to 4, right? Oh, we didn't find it here. Let's go check 5. Cool. Well, if we go any deeper, we'll be in layer 3. So we don't want to go to layer 3 just yet. We go back up and we check 6, 7. I should not count in order anymore, I guess. I don't like the influence that pop culture has over me. 8. That completely threw me off. This is awful. It's like they did it to punish math class or something. Now we realize we're at depth number 3. This is 1, 2, 3. Technically 0, 1, and 2, but whatever. 1, 2, 3 depth. We haven't found the treasure yet. Ignore that we found it right here. Let's pretend the treasure at the end. Can I do that? How do I do that? The treasure's at the end. 6, 7, 8. Now we check 8. Oh fuck, now we're green. We haven't found it at 8, but now we need to go back and check 6, because we don't know. In a case where you don't know anything about your neighbors, we don't know if 6 has a path to go off of, we don't know if 4 or 5 have more paths. If we get to a situation like this, where we can go from 8 back to 4, we just need to check that, you know, we're not, if we've already gone to a node, we just run away. We go right back to where we came from. So that'll be part of our pathing. Then, if we get to this last one here, 9, then we have the treasure. Okay, that's breadth first. Now, let's talk about depth first. Erase my numbers because they're going to go a little bit different. Cool. Oh. Okay. Now, instead of breadth first, we have depth first. Depth first. Traversal. Oh, and breadth first traversal is really good when you have when you have a graph that's really wide. Right, because you don't need to check all the way at the bottom. If your graph is like 20 nodes up here, it's more likely if you're looking for like a random treasure, it's going to be in the first 20 nodes than in the 5 below those. So go check those last, essentially. Depth first traversal says, hey, we want to go all the way to the bottom. We want to go as deep into the graph as we can get. And then we'll check a different path. So what that would look like is we check 1, no treasure here, this is where we start. Then we check 2, no treasure here, so let's go deeper. Check 3, no treasure here, so let's go back to 2 and then take the other path down to 4. No treasure here, but we can go deeper to 5. And then depending on how these two are ordered, you would either check 6 and then go up and then go back down to here, or you would go to 6 here. That ordering does matter a lot in graphs. If it's like a binary tree, it doesn't matter as much. Binary tree is just any node has 2 nodes that follow it. So if we look at like these, the collection of nodes here are a binary tree, right? 1 has 2 children, 2 has 2 children, 3 has 2 children, and so on. Okay. Depth first, you obviously have, it's good when the treasure is further away from the root, right? That kind of makes sense. For graphs that are small like this, it's a toss-up. It does not matter. I will just go with whatever's easiest to implement. Actually, it does matter a little bit. So, something to keep in mind in a maze like this. Let me start a maze and then just break after the first loop. Here. So I can illustrate my point. Boop. Something to keep in mind with a maze like this is that every path has a weight to it, which means that taking paths isn't always equal, and traversing a path will take time. So the first node is here. The second node is right here. You have to move 1, 2, 3, 4, 5, 6 tiles to get to this node. to get to this node here, you need to move 1, 2, 3. Here, 1, 2, 3. But you also don't know that at the start. So I'm going to treat all of the paths as if they have a weight, but I won't know what the weight is. So ideally, in this algorithm, you want to do as little backtracking as possible. Which means that I'm probably going to go with a depth first. So what that would look like is I start here and I go down to here, and then I would go back to here this way. Depending on which direction I choose to go, I picked to go right first, so I guess I would go right here and get the treasure. It's not going to matter. As long as I cover everything, I will eventually get to the treasure. And again, these are small enough. I'm probably never going to run it as a full maze. I suppose I could. What would that look like? What is it, world size? Is it get world size? Yeah. Do I even have enough? Yeah, it shouldn't take more than like 1 million, right? So this case is a little bit more complicated, obviously. Where if you're covering the whole map in a big puzzle, it's going to take some computation. Actually, I want to see if I just run it, where will it get hung up on? I'm playing around. This is not serious coding right now. It is stuck. Oh my gosh, it really bogs down if it gets stuck. Wait, what? Oh. Oh. If it gets bogged down, it just dies. I don't like that. I should check. I should add a check to see if it's moved more than a certain number of times. But then you kind of get into the halting problem, and I don't want to do that. How I solved that before, we can actually take a look at that. Halting problem just means that we don't know if computers are going to stop. There's no general case solution to check if a loop will stop. But for here, I just check if I keep a count on our while loop, and if it gets over 1,000 or over 10,000, it hits an error and it just dies. That's good enough. Okay, that's something to keep in mind. We probably don't want this printing our graph nodes every time. That's probably really bad. Okay. Anyway, let's go back to something a little bit more tenable. Let's go like 10 by 10. Cool. Now we can see the treasures right here, and we gotta go get it. So, now we need to pick a direction. I'm realizing that maybe we need a little bit more in our graph. We need to track what paths we've explored, not just what neighbors we have. So let's add that. That shouldn't be too much work. Explored, and this is going to be a list of directions that we've taken from this node before. So visited, neighbors. Explored. I wish we had objects in this version of Python. It would make everything so much cleaner. Even structs, even if it was like Go and you had structures, or like C. Go and C are very similar. Except for you don't have to manage your garbage collection on Go. Instead, we just waste a whole thread. At least I'm pretty sure Go wastes a whole thread in garbage collection. Okay, now in here I need to add something for explored. If the node's not in the graph, explored will be none. I know explored will always be the direction I just came from, which will be facing. It'll be the opposite of where we're facing. This. Unless it's none. Oh, shit. No, wait, hang on. Cool. Cool. Otherwise I don't need to care about it. Right. Good. Now, we have a list of our explored paths. So what do we want to do? First, we need to decide on what path we go down. Which should just be... I mean, the first one will just be random, right? Which it is. Facing a direction that we just decide. Oh, we already have a function for this. Let me just go there. Take our directions with us. And our current node index. We got from scan node. Current node index and directions. Cool. We'll need to get globally where we're facing. Okay, I also need that for here. Now I need to think through all the cases. Now, if this were like a binary tree, you'd have a parent and you'd have children nodes, but that doesn't really exist in graphs. Because you can have loops and things in graphs that are something to account for. Cool. If we can go forward, let's decide to just keep going forward. Sorry, I'm moving slow because I need to think very carefully about what needs to happen. Okay. That's why this isn't making sense. This needs to change. Again. Explored needs to be a tuple of a direction. And a node address. Right, the neighbors does not need to be the case. I don't need that. So we're to cut neighbors for explored. Okay. Neighbors is not needed. Explored. And so we're going to append the last node address, but it's going to be a direction, which will probably be whichever way we're facing, right? Or no, it'll be the same inverse direction, right? Facing. And then our last node address. So it'll just be essentially like behind us, there's a node at this address that we can go down the path and get there. Right. Cool. That makes sense. Okay, if facing equals none, that means this is the very first node. That means this is the first node. Very first tile. And so the explored direction should be none. It should just be an empty graph. If neighbor in explored. So we're going to check if we already have a neighbor. Cool. And if we don't have this neighbor, we add it. It's behind us. Cool. Not in graph, visited, explored. So this is the case here. Where the node's not in the graph. Okay. So then explored will be spacing equals none and last node address does not equal none. That's also important to check. Okay. Is this accurate? So this is just the node's not in the graph currently. And this is the node. This node is not the first one in the graph. We can do this. Do we already check that though? Explored is already set down here. Hang on. Important thinking. Explored is set here. Let's think of a case where the node is in the graph. So it's not the first. This just adds it if it's not there already. This updates the neighbor if it's not already there. So I don't need this bit of code here. Unless it's the... No, because it can't be the first tile. Right? So we add the node and then we update the explored. Here. I think that's fine. Now, what was I doing before I was looking at that code? Was there a reason I was looking at that code? I was updating how explored works, how the neighbor's code works. I also am not printing anything at the end of this one. Quick print. Graph.nodes. And then this is just our treasure tile, which is 9.4 here. Yeah. We don't start on a node here, so we won't have it in the graph. That's fine. That is okay. I'm gonna restart till I get one, though. There we go. 0, visited true, explored, none. Cool. Cool. Now. Now what happens? Okay, so we pick a direction to move. First, I want to check if the current node index graph.nodes, current node index, 1, explored. If this is empty, the length of this is nothing. Then we're to do one thing, which is just pick a random direction to go in. Which is going to be, hang on. Actually, is this going to be exactly this code? Pick facing path. I'm going to drop this as a negative condition. So if we don't know what direction to go, we pick a random ass path. And then that's fine. Because what I'm missing here is that we need to update the explored direction when we get to the next node in the path. Right? Right. We add we add our link to the last path. So the current node index gets to know where the last node address is, and then the last node address needs to know where we are. Right? neighbor and explored, and then we need to check the last one, right? So it's literally just gonna be the same thing. Well, for neighbor in, well, I guess, should I just make this a function? I'll make it a function in a second. Why did the music not start? Okay. And then this will be the last node address. Here. Cool. Oh, but this is the address, not the actual index. Okay. Last node index, we get graph.get node address. So now we go grab the last node index, we grab their explored table, and we run this exact same thing here. Should be last. So last node index 1 explored, append, directions toggle facing, node address, right? Yes. I'll make that a function eventually. So now, whenever we go to a new node, we get the new node understands that the last node is connected to it behind us. And then the last node, we actually need to track this. Last node facing. So before we move at all, hang on, no. I need to not get distracted here. Also, I think I can define global like this. Let me try that. Okay. So now, the current node knows that behind it, there was a node that we just came from. If there was. And the new node, the last node, knows that there is a node in front of it that we just got to. Cool. Last node facing now needs to be updated right before we move. Cool. Now let's go back to pick facing node. Cool. That actually cleans things up quite a bit. So now we check if it's 0, we pick a random facing path, and then we go with that. Right? Else. What do we do on else? Otherwise, we check for dir in this. Oh, wait, if this is 0, this is 0. We just go here, right? No, we want a direction in directions. And we want to check if dir is not equal to a direction we've explored. Hang on. This is significantly more complicated. I'm gonna write this out the way I was thinking. And then I know it has to change, so... Actually, maybe I'll run it as a demo for why it doesn't work. So now we check if we've gone down a path we have not explored yet. I think actually a breath first search is going to be easier to implement, but we'll cross that bridge when we get there. Okay. Also, now that I'm thinking of it, you should not be giving it an address, you should be giving it an index. For explored. Just because it clears things up a lot. But no, I need to do that first, unfortunately. So this will be node index. Last node index. That's fine. Do I need last node address anywhere? No, because I just recalculate the index anyway. Shoot. Well, this will need some changing. If neighbor, it should be like neighbor 1, right? With the index. Sure, that's probably fine. Also, right before I move, I need to set all of this stuff. So, last node index. Do I ever get the node index? No. What does scan node return? The node index. So yes. Here we go. Last node index is this. Last, what is it? Last node facing? No. Equals facing. Cool. That's set now. Now I don't need to worry about that. Also, if you're concerned about how messy this code is, yeah. That's what happens when we can't use classes. The code gets really gunky. There's a reason they invented classes. Structs do everything classes do, just way worse. Not worse, less readable, which I think is worse. Subjectively worse classes are structs than classes. I know this because I've written a lot of Java and a lot of Go, and I can compare them quite simply. I can read the Java, and the Go is a decipherable mess. It's still decipherable, it's not like it's unreadable. But it's a mess. And then again, I am weird. I'm like one of the few people who think that JavaScript is pretty nice. JS frameworks are pretty nice. I don't know about just base JS. Okay. Cool, that should be fine. Now. Pick facing node off the current node index. If the length of the current node index is 1 equals 0. But I don't need this, is what I discovered. I just don't need that check. So now we're going to loop through the possible directions we can go. And we say if this direction does not equal, if we haven't gone down this path before, we will return that direction. Now, this won't work, but we're going to run it, because I want one check for errors and I want to see what happens. There's an error in crops and maize. Oh. Hi, Snack. You want to talk on mic? Here, I'm going to give my cat the mic. Excuse me, lots of noise. I don't have a sound dampener for this mic, so it's just noisy every time I move with the mic. Maybe I should purchase one of those, given that I stream a lot. Okay, what is freaking out here? There shouldn't be any code here. Damn it. Why is this such a pain in the ass? Okay, we need the node index, but it's not here because it's here. Oh, wait, I can define this a little bit better. There we go. Okay, what is it freaking out about now? None cannot be used in index on great news. Great news. Current node index is none. But this is a node. So how is it that we've scanned the node and determined that the index is none? Return node index, which is decided here. Graph.getNode address. Do we get it again after we add node index equals graph.getNode address? Get node. I see what the mistake that I've made. Well, shit. Maybe I need to store the index and the address then. In here. I already got it. You know, some days I am oh, wait. I think I'm an idiot. Oh, fuck. I'm stupid. How am I stupid? What did I do? How did I mess this up so bad? It does exist. What's its index? Is 0? 1. This is frustrating. If node 0 equals address. So what is node 0 set to? Oh, I can print this, right? Quick print. I should add proper debugging to this at some point. Adding node address. Visited. I'm realizing that visited is not necessary either. It is later, actually. Visited. It's not strictly necessary, but I'll use it. It's actually not really necessary at all. I'm taking visited off. The reason I'm taking visited off is because, and I'm just going to make this a list. 2 options. Address and then the second one. Should really just make this a dictionary with address. Right? The amount of times this structure has changed really grinds my gears. It's going to make the code more readable, though, which is important. Explored. So now we just go node index explored and node index address, and we're set. We're all good. Also, I should probably move this into the graph as well, just so it's a little bit simpler. Everything can be in one place. Okay. Okay. Yeah, does that change anything down here with the... Yeah, it changes this. Basically, anywhere I've got a 1 or a 0. Which could change. Cool. That'll probably cause me issues. What was I trying to solve? What was the error? Oh, it was printing stuff. Okay. Add node takes 2. I called it with 3. Oh, I also called it with 3 up here, right? In scan. Error 0 is not a key in the dictionary. Oh yeah, you're right. It isn't. Okay, I tried to call something that is not a function. You are so right, bestie. Last node facing equals facing. Oh. Wait, hang on. I've already done this. A new error. None cannot be used as an index. Okay, so now I'm back to the original issue. Adding node address. 9, 0. Cool, so that's great. Did add error, none cannot be used as an index. How am I getting none? Hang on, I need to check my schedule for tomorrow because I need to know if I need to call it quits. If I don't have like a really early meeting, I can stay up a little bit later. Thursday. We should got a regular morning stand-up meeting. Cool. Okay, I have a hot take. If you can, if everyone's schedules work out, put your stand-up at the end of the day. Put them at 4, 4:30. But fuck it, put it at 4. 4 is fine. Because I need... I'm gonna gripe about me for a second. I need like a good 20 minutes to boot up. When I sit in my chair, I need 20 minutes to like get in the zone, right? Okay. Then, if that hasn't happened, and you sit me down right at the start of the day, right at like 9 a.m., 9 or 10, and you pepper me with questions about what I was doing yesterday, what I plan to accomplish today, I don't have answers for that at 9 in the morning. I'm just gonna talk, and it's not gonna work, and you're not gonna get any insight. Put your stand-ups at the end of the day, so that At the end of the day, everyone, one, wants to move on, so things are concise and quick. Two, that means we're not wasting any time for the business folks. You save money when we put stand up at the end of the day. Two, I've already done all the shit I'm going to do for the day, so I can just tell you I did this, this, and this. Easy peasy. This is better for everyone. This goes quickly. It's very simple. I mean, it's foolproof, honestly. The biggest problem is that, you know, if you've got like folks all over the globe or whatever, you really can't do that. Because what is it? Where's Britain at? Where is Britain? Britain's a few hours ahead. Right, so their day, our end of the day is like 7 p.m. for them, or whatever. And you got East Asia, which is exactly flipped for the Americans. So unless they're pulling all-nighters, you're not getting them at 5 p.m. EST, right? Or at 4 p.m. EST. So that's like your issue. But in the scenario where you have the resources to do it like this, because it's costing you less resources, and the teams are set up in a way that you're all working at the same time, put the stand up at the end of the day. Please, please. Okay, that's enough. Do you want to talk on mic, Snack? You want to talk on mic? Snack is my cat, by the way. If you type !snack in the chat, it will take you to a link of a website about my cat. He's pretty cool. And evil. He does not like that I'm speaking to ghosts in my computer. Not that you're ghosts, I'm sure you're lovely. What was I doing? Oh yeah, get note is returning none for no reason. It's returning none no matter what, because I'm a dumbass. What does this need to return? The node index? I fucking hate myself. Okay. That was an easy problem I should have got. Reddit error now? Or is it just freaking out about this? I see. That was my issue. Cool. Now, let's let this run for just a little bit, and we'll see what happens. Error. No, that error's done. Solved it. I don't want to print the graph, so I'm just going to comment these two out. Okay, so it gets the end and it's not turning around, which is not my favorite. Why is it not turning around? I mean, it pathed pretty well up to here. Okay. The weather's pretty nasty. I won't leave. I was gonna call stream and go get food, but I can't do that. I don't want to drive out there. The weather's nasty and mean. Unexpected movement failure. Where does that happen? Here? So if the direction we pick is not something that we've explored yet. We go in this direction. Otherwise, we pick our facing path like this. So this should just turn us around, right? But it never actually turns us around. So what's really happening? I'm actually going to move. Let me check this again. Okay. Wait, what? Maybe that could be part of my trouble. It should definitely be running. So got this neighbor's false. Explored, which explored should be empty. So if neighbor equals the last address, but we don't need to check this because it's empty, then this will be true. So yes, this should run. Graph nodes, node index, explored, dot append. Snack, what's wrong? Where? Come on, where? I think he needs to go play. Direction toggle facing last node index. What if there isn't a last node index? What if this whole block is not running? Oh, I missed a comma. Last node index is none. So what happens then? It's a truncated output. I'm gonna try running this again. Adding node address, adding node address. But the last node index is always none, which is just not correct. I'm gonna take the global off this. I don't think it's necessary. Still none. But I set it when I move. Oh, I set it when I move. There we go. Okay, so that solved one. What is this case? So this is one where I had another movement failure. I also still don't see it actually updating the nodes correctly. So we started here, then we went up to here. So this should be a node, right? So should this. Hang on, I'll be right back. Okay, I had to feed my cat. So scan node, pick our address, we get the current index, if there is one. If there is no node in the graph, or if our node currently is not in the graph, we don't need to visit it, I'll just take that out. Explored is nothing. Then we add address and explored, which means I can just add address and a nothing list to make it simpler. And then we get our node index from that. Then we check our last node index, because we want to update the explored table. That should be happening here and it's not. Let me actually just check is node. When's the true case here? See if this is properly identifying the nodes. Wait, where's my error? Oh, address. Okay, no, it's looping. Okay, so it does know that it's a node. Node assigned to index, node index. Facing. We need a comma. There we go. And that's just printing. Make it a quick print. Okay, so we add a node, and then the last node index is none. Node assigned index is 1, facing is east. Maybe I need to set it, so when I set it, I add global, and when I check, I don't care. Right? Is that the pattern I'm seeing? I think that's the case. Let me just double check. I'm getting an error now. Last node address has never been assigned. Oh yeah, because this doesn't even make any sense. I changed it down here, right? Okay. Facing east, unexpected movement failure. Why is it still facing east? Shouldn't it turn around? facing direction. I'm gonna have those regular print turnaround. So it's facing north, but then it just never picks a new direction? Facing node. Turn directions. Okay, let me go through and just clear out all of my other quick prints that are not really necessary. I like that one. I can take out the add node because I know that's happening correctly now. I don't care about node at. Okay. Now I want to check. Quick print. Directions. I feel like I've got an idea of what's going on now. Wait, what? Why did it never print this? You know what I need to turn back on? I turned it off because I thought it was annoying. Errors? General. Code highlights. It should be enabled. Moving too fast. Okay. So is it just not running pick facing node? No, it is running. At the very least, it should be running this. Right, because this is being run. So this has to be being run, and this quick print is never running, which is very interesting. Why? Why would it not be running? Quick print, directions. Why did the music just do that? That was strange. Dirt does not equal graph.nodes. Well, that's fine. This just is no printing. Oh, it is. I can't read. Let me zoom way in. So we've got one direction, west. So it's going east? Why is it going east? It has a direction it can move. Snack, stop it. Okay, so it's gonna look at west. And if it's not explored, it'll return there. But it is explored. Because we just came from that way. Otherwise, you pick the facing path. Now, if we can move in the direction we're facing, we return. Otherwise, we loop through our directions, which are west. And if we can move west, and the direction is not toggled, right, so we're facing east. If we can move west and the direction is not west, we go there. Otherwise, we just turn around. We go west. Quick print, like facing? That should probably work. No. It's not getting here. Does it think it can move this direction and it just can't? Snack, stop it. Stop. You're gonna be okay. You're gonna wait like 10 minutes. Can you wait? Come here. Nah, he thinks it's bedtime. Hey, buddy, stop it. Okay, hang on just a second. He's just yelling for no reason. I don't know what that's about. Okay. I need to solve this last problem, and then we'll do the actual pathfinding, or the actual search some other day. I thought I'd be able to do this in 4 hours. I don't know why I'm having so much trouble. Wait. That's my issue. Wait, this doesn't need to return anything at all. That's not how this one works. Cool. Now it's still getting caught in a loop. At least it's not erroring. So that's where I'm gonna leave it, because I need to go make food. I'm hungry. Yeah, that's the end. That's the end of the stream. Thanks everyone for hanging out. I will see you guys. I don't know, some other day. Maybe tomorrow. Maybe the day after. Who really knows?